So let's do an example. 5x to the 6 minus x cubed plus 1. Another example of Descartes' Rule of Signs. Coefficients are 5 minus 1 and 1. So there are two sign changes, 0 or 2 positive roots. Of course, if I were to plug in negative x in place of x, I get 5x to the 6 plus x cubed plus 1. So I know there's no negative roots. And this is all Descartes' Rule of Signs tells me. Now, if I wanted to do further investigation, though, I could always write this as x cubed squared minus x cubed plus 1 and use the quadratic equation to try to solve for x cubed. And then I'd see, well, when I took my b squared minus 4ac, I'd run into a little bit of trouble. But this here is what Descartes' Rule of Signs tells us. Now, let's look at another example. Let's say we wanted to look at x to the 10th minus 1. Okay, well, big number, but easy for us to do. The coefficients are 1 or minus 1. So there is exactly one positive root. And of course, if I were to plug negative x in, I also get x to the 10 minus 1 because, well, the negative goes away because it's taken to an even power. So I also have 1 and minus 1, so I get exactly one negative root. Of course, it's kind of obvious what the negative and positive roots are in this situation, right? They're 1 or negative 1. And the rest of the roots are all complex. Of course, it does have 10 roots, but that's not something that we conclude using Descartes' Rule of Signs. Let's do one more example. If we had had something like x to the 9 minus 1, or just to make it interesting, minus 17. 5x to the 9th minus 17. So I get 5 and I get minus 17. So this tells me there's one positive root. But if I plug negative x in place of x, I get now minus 5x to the 9th minus 17. So there's 0 negative roots. So this tells me there's one positive, no negative roots, and the other roots all must be complex.